Hello, going to do a quick rundown of reciprocal frames and geodesic domes and Houdini. So this is meant to be like a quick setup so you can mess around with geometry and get an idea for what you want to create. So basically creating something like this. So here's like a tri-frame on a metaball shape. Here's like a quad frame. Here's a quad frame on a tunnel. Tri-frame on a geodesic dome. And this is a hex grid, so then you can, you have the basic controls like space, extend these ends a bit. You can do like basic booleaning to get the notching intersections. So you can get the notches like so, and then you can lay all the members out to inspect the unique pieces. Okay, so gonna run through the node tree. So here, let's take just a look at the dome for now. So here, I'm just using a platonic solid. So you can also use the platonic solids SOP, for example, if you want to create a geodesic dome like so. Okay, and then here I'm deleting the bottom. If you want even frequencies, so like a 2V or 3V, you can just use the loop subdivision, but if you want odd divisions, you have to use like an edge divide, and here you can also get even divisions. So this will divide the edges and then just add a divide with always small angles turned on, and that will give you proper results. And I just have this running inside of a for each primitive loop otherwise the edge divide won't be able to connect the points properly. You just have to isolate it to a single primitive. Okay, and then I'm raying it to a sphere. So right here, all the edges have equal length, and this breaks that up like you would normally do for a geodesic dome. Okay, so that's the basic geodesic dome creation. Here, this is if you want to create the reciprocal part now. So just computing the dual polygon. Here I've just got some stuff. I'm just removing the triangles at the bottom, which will create artifacts. Then I'm beveling the points. So I've got a set of points, just beveling like so. I'm adding point normals, and then I'm rotating these polygons. So you can see I've got it set to rotate the point fillet polygons group right here. So I'm rotating this, and you can see I'm doing this. I'm looping over primitives. I'm getting every point, and then I'm rotating those points around the primitive normal. Here I'm just translating it back to local space. So I'm transforming the primitive back to the center. I'm rotating it when it's at the center, and then I'm transforming it back to the world. And here, that's where all of the attributes are getting written out. Okay, then I just convert the not point fillet edges, which gives me these outer edges. I promote the point normals from earlier here to primitives. That way they can be used in the sweep node. This is a primitive attribute. And this will orient them properly to the geometry. Then I group the ends just by length of the sweep width times a tolerance factor. And I just extrude those ends by however much I want. Here I just add to the length attribute. Then I remove these interior edges and the inline points like so. Okay, then I just extrude the members for depth, and that's pretty much everything. Just extrude these ends a bit more. Okay, here this is just to extract the transforms to lay out all the members like this. So it's pretty much just grabbing, here I'm just grabbing the top of the member and the bottom of the member, like so, and then I'm just computing the directors between them, and then I'm doing the same. And then I'm using match axis after, aligning it to the bottom, extracting the transform, then copying the transform back to the source geometry. So now I've got a transform attribute on all of these. And then I'm just booleaning the notches right here, and then that gives me the final result. So that's all. Quick overview with minimal vex and pretty easy to set up.